Control devices are fitted into the system to ensure maximum efficiency and to protect components from damage. A thermostat is used to sense the temperature of the evaporator fins and help ensure that they do not drop below 1 degree Celsius. If the temperature of the fins were to drop to 0 degrees Celsius or less, moisture condensing out of the air would freeze on the unit and block the airflow through the evaporator. When the fins of the evaporator drop to 1 degree Celsius, the thermostat contacts open. This breaks the electrical circuit to the compressor clutch and stops the compressor from circulating refrigerant. When the evaporator temperature rises, usually to about 4 degrees Celsius, the contacts close and the electrical circuit to the compressor clutch is restored. The fixed orifice tube cannot alter the amount of refrigerant entering the evaporator. Therefore, as extra cooling is required and the heat load on the system increases, the compressor cycles on for longer periods. As the heat load decreases, the compressor cycles off for longer. This cycling adjusts the system to the heat load. System protection against high pressures is provided by a high pressure switch mounted in the high pressure line between the condenser and the orifice tube. High temperatures and pressures may develop if the condenser is unable to transfer its heat effectively to the outside air. This may be due to blockage of the condenser fins or an inoperative electric fan. If this occurs, the high pressure switch open circuits the compressor clutch and prevents the compressor from circulating refrigerant. If a leak develops and the refrigerant is low in charge, a low pressure switch on the low pressure side of the system turns the compressor off when the system pressure falls below a set value. As lubricating oil is carried around the system by the refrigerant, this prevents damage to the compressor due to lack of lubricating oil. In a fixed orifice tube system, the components necessary for system operation are the condenser, the evaporator, the compressor, the orifice tube, the accumulator, connecting pipes and hoses, a thermostat, blower fans and pressure switches. The orifice tube is located between the condenser and the evaporator and provides the restriction to flow necessary for system operation. When the air conditioning system is switched on, an electromagnetic clutch is energized on the compressor drive plate and the compressor is driven by the engine crankshaft. Vaporized refrigerant is drawn from the low pressure side of the system by the compressor. It is discharged from the compressor as a high pressure, high temperature vapor and flows to the condenser where it is cooled by the air flowing across the condenser coils and fins. The reduction in temperature causes the refrigerant vapor to condense and turn into a liquid, which flows to the filter and then to the orifice tube. The liquid refrigerant loses pressure by flowing through the fine tube and is then forced to expand suddenly by passing through the nozzle and entering the larger volume of the evaporator. The drop in pressure causes the low pressure, low temperature liquid to boil, and this liquid mist evaporates rapidly in the evaporator coils, absorbing heat from the air passing across the external fins. The cooled air is directed to the interior of the vehicle by blower fans. The refrigerant in the evaporator flows onto the accumulator. The accumulator acts as a storage volume for the refrigerant and also separates liquid from vapor. Refrigerant vapor enters at the top of the accumulator. Any liquid refrigerant falls to the bottom. The accumulator is made from aluminium and has a large surface area. This assists the final evaporation of any liquid refrigerant leaving the evaporator. Refrigerant vapor is drawn off from the top of the accumulator through the outlet tube by the compressor. At the bottom of the outlet tube is a small hole which allows a small amount of any lubricating oil that settles at the bottom of the accumulator to be drawn to the compressor. The accumulator also contains filters and desiccants, which remove impurities and moisture from the refrigerant as it passes through. While air conditioning removes heat from the vehicle interior, it also reduces the amount of moisture in the air or relative humidity in the passenger compartment. This moisture is collected in a tray below the evaporator and is drained away to the outside of the vehicle by means of a rubber tube. The reduction in the humidity of the air further promotes body cooling by the more rapid evaporation of perspiration. This section examines the thermostatic expansion valve system. In a thermostatic expansion valve system, the components necessary for system operation are the condenser, the evaporator, the compressor, the receiver dryer, the thermostatic expansion valve, connecting pipes and hoses, a thermostat, blower fans, and pressure switches. The thermostatic expansion valve, also called a TX valve, is located at the entry to the evaporator and provides a throttling or restricting function to control the quantity of refrigerant entering the evaporator. At the same time, it must provide for complete vaporization of all the liquid refrigerant which enters the evaporator. The system is charged with refrigerant and a quantity of lubricating oil, which circulates with the refrigerant at all times. When the air conditioning system is switched on, an electromagnetic clutch is energized on the compressor drive plate, and the compressor is driven by the engine crankshaft. Vaporized refrigerant is drawn from the low-pressure side of the system by the intake side of the compressor. It is discharged from the compressor as a high-pressure, high-temperature vapor and flows to the condenser where it is cooled by the air flowing across the condenser coils and fins. The reduction in temperature causes the refrigerant vapor to condense and turn into a liquid which flows to the receiver dryer. The receiver dryer acts as a storage volume for liquid refrigerant and also contains a filter and desiccant or drying material. The liquid refrigerant must pass through the filter and desiccant to reach the pickup tube where the refrigerant can flow on to the TX valve.